Hello Algebra 2 students, and welcome to our live video of our online learning. Today's April 1st, 2020, and we're going to be doing the next lesson that we left off with when we were in school. What you need today for the materials are, you need the paper plate that we started when we were in school, and if you don't have one, maybe you can grab a paper plate at home and copy everything from here. You can always pause the video so you can stop and take note of that. You need your binder of notes. You need a blue colored pencil or pen and a regular pencil. And today what we're going to learn is we're going to find the sine, cosine, and tangent, if you remember we're in trigonometry, of an angle of rotation to a point xy that is not on a unit circle. What we're going to need in our binders are 4 pages. Pages 358, 64, 63, and 65. We're going to do some exercises on those pages after we do our paper plate work. And tonight for your homework, you're going to be on page 362, only do 7 and 8. Pages 366, 367, do 1 through 8. And I'll probably put a very few Delta Math problems up for you to practice. So first of all, we're going to start with our paper plate. And if you remember, what we were doing is we were finding the sine and cosine of this angle called theta of rotation if the point that we were looking for of that angle was on the unit circle. This is a unit circle because the radius is equal to 1. So this point called xy, if you want to know the sine or cosine of this angle theta, you can get the cosine by knowing what this x value is. You can get the sine by knowing what this y value is. And the equation of any circle with the center at the origin is x squared plus y squared equals r squared. And since this is a unit circle with a radius equal to 1, the equation of this unit circle is x squared plus y squared equals 1. Well, we're going to take a point that's not on the unit circle today. And we're going to take our blue pen or pencil, and we're going to make a circle around the embossed portion. There are a couple of embossed circles on here. You can take either one you want. I think I'm going to take this one and just draw a circle around here with your blue pen or pencil. Like I said, you can pause if you need to go get some materials. So here's a circle that we just created. The center's at the origin, and this is not a unit circle. This blue one is not a unit circle. And what we're going to do is we're going to put a point on this blue circle, and I've kind of got it messy up here, but if you want to put a point over here in quadrant 2, and you can mark this point x comma y, and what you want to do is you want to take a straight edge and drop a perpendicular down to the x-axis, and you want to draw from the origin, which is the center of the paper plate, here to the xy value. And what you've created is a right triangle here. And the height of this is this y value. And the length of this leg is this x value, but because we're going backwards, because we're going into the negative x direction, this is actually a negative x comma y. And this radius, we don't know what it is. It's not 1. It's something bigger than 1. We can call this radius capital R. So what I'm going to do is I'm going to have you change, if you've got this equation here, the equation of this blue circle is x squared plus y squared equals r squared. So if you can take that 1 that you created here and call it r squared, because this is r, and this radius is equal to r right here. So the next thing we're going to do is we're going to mark our angle theta. So there's an angle theta that is an angle of rotation. If you remember what we were doing before, we were rotating around. Some of our Delta Math problems made us do this. We're going to rotate around. So we have an angle theta that comes around like this. So this is our big angle theta. But you can also create the reference angle. The reference angle is this angle that is made with the x-axis. So we're going to call this theta right here. And that's this angle right here, the reference angle of the angle of rotation. what we're going to do is we're going to use a little bit of SOHCAHTOA, because we know that the sine of this angle is opposite over hypotenuse. The cosine of this angle is adjacent over hypotenuse. Let's mark this x. And the tangent of this angle is the opposite over adjacent side. So down here in this, for this blue triangle, we're going to mark that the sine of this angle right here is equal to opposite over hypotenuse. The cosine of this angle theta is equal to the adjacent side over the hypotenuse. However, because this x is going negative, we're going to put a little negative in front of that cosine, and the tangent of that angle, opposite over adjacent from SOHCAHTOA, opposite side is y, and the adjacent side is negative x. So we've got sine, cosine, and tangent of this angle theta, which is really this big angle of rotation right here over in quadrant 2. The equation of this this triangle, x squared plus y squared equals r squared. You can also say, you can take the square root of both sides. We can also say, if we need to find this radius r, we can also say that r is equal to the square root of x squared plus y squared, taking this just the square root of both sides. Now what we're going to do is we're going to talk about each one of these quadrants here. We have quadrant 1, which are all angles that are created over here. And in quadrant 1, all three trig functions, sine, cosine, and tangent, all of them, which are sine, cosine, and tangent, are positive. All of them, because if you pick any point x, y on this blue circle, the x is positive, the y is positive, and positive over positive is going to be positive. Over here we have quadrant 2, and in quadrant 2, the only trig function of these three, sine, cosine, and tangent, is the sine is positive. So only the sine of theta is positive for any angle that's created in quadrant 2. Only the sine is positive, cosine is negative, tangent is negative. If we created an angle down here in quadrant 3, if we were to rotate all the way around and have an xy value down here, because we're in quadrant 3, the x goes negative and the y goes negative. If we were to land on a point somewhere down here on this blue circle, the sine would be negative, the cosine would be negative, because negative over positive, the r value is always positive, but tangent would be positive because you would have a negative y over a negative x. So in quadrant 3, any angle between 90 and between 180 and 270 degrees, only the tangent of theta is positive. And then over here in quadrant 4, if we were to rotate an angle all the way around and get over here to quadrant 4 and try to find the sine, cosine, and tangent, well, x is positive, but y is negative if we were going to connect this and make a right triangle. So in quadrant 4, only the cosine of theta is positive. And you're going to have to remember in which quadrant what trig function is positive. Sine, tangent, cosine, or all three of them are positive. So that's about all we're going to be putting on our paper plate for right now. And what we're going to do now is we're going to go over to page 358 in your notes. We're going to talk about what some of these things mean on your unit circle. So, first of all, we were just talking about the sign, positive or negative, of each of the three basic trig functions. And the three basic trig functions, remember, are sine of theta, cosine of theta, tangent of theta. whose terminal arrays lie in a given quadrant, quadrants 1, 2, 3, or 4. And so we're going to try to remember which is positive, which trig function is positive by this little acronym. And this is just a little trick. It's worked for students for years. And if you can remember the little phrase, which may or may not be true, but all students take chemistry, is just a phrase that says, in quadrant 1, all trig functions are positive. S for students, well, S stands for students, and S starts the word sine. So in quadrant 2, sine is positive. T, take, well, this T stands for tangent, and in quadrant 3, the tangent is positive. C, chemistry, well, chemistry is also the starting letter of cosine, so in quadrant 4, the cosine of theta is positive. So what we have here is quadrants, these are the quadrants, and these are the trig functions. And in quadrant 1, the sine is positive, the cosine is positive, the tangent is positive. But in quadrant 2, the sine is the only trig function that's positive, cosine and tangent are negative. In quadrant 3, sine is negative, cosine is negative, but tangent is positive. And over in quadrant 4, sine is negative, cosine is positive, and tangent is negative. So that's just a little way to remember this. And so what all students take chemistry means, it's just a trick, like I said. It's just a trick, and this trick will help you remember what quadrants. Let's see if this will write a little darker. No, it's not dark enough. So this trick helps remember REMEMBER which trig functions are positive in which quadrants. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take chemistry. And down here, sometimes we see questions asked like this. If the sine of theta is less than 0, well, less than 0 means negative. And if the cosine of 0 is, or cosine of theta is greater than 0 means positive. Which is the quadrant where sine is negative and cosine is positive? Well, down here in quadrant 4, cosine is positive. That's the only one. So this is quadrant 4. Which quadrant is the sine greater than 0, which is positive, but the tangent of theta is less than 0, negative? Well, where is sine positive and tangent negative? Well, you can look up at this chart if you want. You can look over here. This is in quadrant 2. Sine is positive. In which quadrant is the sine positive and the cosine positive? Well, the only quadrant that happens in is quadrant 1, where they're all positive. Where's the cosine negative, but the tangent positive? Well, right here in quadrant 3, tangent is positive, cosine is negative. And then the next two, you could probably do these on your own by now. Where is the tangent negative, but the cosine positive? Well, the only place cosine is positive and other things are negative is over here in quadrant 4. And where is the sine negative and the cosine also negative? Well, if both sine and cosine are negative, you can look up here, sine and cosine are both negative in quadrant 3. Next thing we're going to do is we're going to talk about quadrantal angles. No, I guess that wasn't part of what we were going to do. We were only going to do exercises 3 and 4. Let's move on to page 364, exercise number 4. So what we have in exercise 4 on page 364 is we're going to talk about a point P in the coordinate plane, but not on the unit circle. Well, that's what we just made with our paper plate is this blue is not a unit circle because the radius is greater than 1, or it's not equal to 1. So if you have a point P that's not on the unit circle, and you're asked to find sine and cosine of the angle that it creates, you have this little 4-step method. First of all, you're going to plot the point that they give you, and just like we did on our paper plate, we're going to draw a segment that connects the origin to that point P, just like we did on the paper plate, and we're going to mark theta, which is the reference angle. We're going to draw a right triangle using the x-axis, never the y-axis, to drop this down. We're going to use Pythagorean theorem to find the hypotenuse, and then we're going to do SOHCAHTOA. SOHCAHTOA says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Or you can memorize what was on your unit circle about the sine being y over r, cosine being x over y. Oh my gosh, I made a mistake. This one should be x. Take your paper plate. I'm very sorry. This should be x over r, negative x over r. Please change that. I'm sorry. And then the tangent is y over negative x. So right now we have an example of, they're giving us a point P at negative 5, 12. So if you want to take negative 5, which might be about right here, and 12, which would be about up here, and plot that point, negative 5, 12, what we're going to do, we did step 1, plotted the point. Now we're going to connect this to the origin. And step 3, draw your perpendicular down to the base, creating a right triangle. Well, the height of this is 12 because you're up 12 on the y-axis. This base is 5, and what you want to do is find this r value, and r is equal to, you can do this Pythagorean theorem. You can say 5 squared or negative 5 squared plus 12 squared equals r squared. Well, this is 25 plus 144 equals r squared, and then 169 is equal to r squared, so r is equal to 13. This is a 5, 12, 13 triangle, if you remember your Pythagorean triples from geometry class. So since we know that this side is 5, this side is 12, and this side is 13, now we can do SOHCAHTOA to get the sine. Sine is opposite over hypotenuse. So the opposite side is 12, and the hypotenuse is 13. The cosine is adjacent over hypotenuse. The adjacent side is 5, the hypotenuse is 13, but you have to make it negative because if you're in quadrant 2, cosine is negative. Which quadrant did this fall in? This fell in quadrant 2. Over here on this next example, we've got a point P called 1, negative 7. So you're going to go over 1. You're going to go down negative 7. You're going to plot that point down here. You're going to connect the point to the origin. You're going to drop the perpendicular up to the x-axis. Never use the y-axis. And you've got a right triangle. The length of this side is 1. The length of this side is 7. And then you can do a squared plus b squared equals c squared, or the radius squared. This is 1 plus 49, which is 50. 50 is r squared, so the square root of 50 is r, and if you wanted to break that down, 25 times 2, this is 5, square root of 2 is equal to the r value. R's are always positive. Sine, and that's this side right here, this hypotenuse right here. Sine is opposite over hypotenuse, so that is, the opposite side is 7, the hypotenuse is 5, square root of 2, but because we're in quadrant 4, the sine is negative. Well, the cosine is adjacent over hypotenuse. This adjacent side is 1, the hypotenuse is 5, square root of 2, and because we're in quadrant 4, cosine is positive, and that's it. So this is for a point. If you're given a point that's not on the unit circle, just follow this technique and you'll be able to get the sine, cosine, and even tangent if you need. The next thing we're going to do is we're going to flip back to page 363, and we're going to do exercise 2 on page 363. Exercise 2 says we have an angle theta. It has a terminal ray that falls in the first quadrant. That's an important part of this. And the cosine is 1 over 3. Well, if you remember from SOHCAHTOA, of course you do, cosine is adjacent over hypotenuse. It says determine the value of sine of theta in simplest radical form. Well, we have something called the Pythagorean identity. Cosine squared plus sine squared equals 1. So I would like you to get your paper plate back again. And the paper plate, because this unit circle has an equation, if you remember from before vacation, x squared plus y squared equals 1. That is for the unit circle. Well, if x is the cosine of theta and y is equal to the sine of theta, then what you can do is create this Pythagorean identity that says the cosine of theta squared plus the sine of theta squared is equal to 1. This is a really important part of trig. It's called the Pythagorean identity. So all you're doing is creating this equation of the unit circle, x squared plus y squared equals 1, replacing the x with the cosine of theta, replacing the y with the sine of theta, and then you've got this new equation. This new equation is up at the top of page 363. It's really, really important, so you should highlight this. And on another day, we're going to get our calculators out and show how this works. So if you know that the cosine of theta is equal to 1/3, then what you can do is you can substitute in for this cosine of theta 1/3. So you can say 1/3 squared plus the sine of theta squared is equal to 1. From right up here, substituting that 1/3 in. 1/3 squared is 1/9 plus the sine of theta squared is equal to 1. If you subtract 1/9 from each side, you get the sine of theta squared is equal to 1 minus 1/9 is 8/9. And then if you take the square root of each side, you're going to get the sine of theta is equal to the square root of 8 over the square root of 9. That's the square root of 8/9. The square root of 8, you can break that down into 4 times 2, which is 2 square root of 2, and the square root of 9 is equal to 3. And because we're in the first quadrant, the sine of theta is positive. So there is your value for sine of theta. That's one way of getting it. Now there's another way of getting the sine of theta by just drawing a right triangle, knowing that the cosine is adjacent over hypotenuse and this is in the first quadrant. So if you have a point, let's say we're going to take this point into the first quadrant. Let's connect it to the origin. Let's drop it down to the x-axis to create our angle theta here. And cosine is adjacent over hypotenuse. And what we want is the sine of theta, and sine is opposite over hypotenuse, so we're missing this side right here. We can use a Pythagorean theorem. We can call this b. 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. B squared equals 8, so b is equal to the square root of 8, or 2 square root of 2. And now SOHCAHTOA says the sine of that angle is equal to the opposite over hypotenuse, SOHCAHTOA, and the opposite side, which is b is equal to 2 square root of 2 divided by the hypotenuse, which is 3. And you get the same exact answer using 2 different methods. It doesn't matter which method you have to use unless they tell you to use a Pythagorean identity, then you have to use this method. So that's page 363, and then the last one is page 365, exercise number 2. Exercise number 6. So number 6 says, we have a point E on a circle whose equation is x squared plus y squared equals 625. Well, we know this is r squared is equal to 625, so we can probably figure out r. And what they're asking for, if the angle is drawn in standard position, we're going to, let's draw a beautiful point E, -7, and then we're going to go down, way down to -24, draw that point down here, connect it to the origin, drop a perpendicular up to the x-axis. So this length is 24, this length is 7, and you can figure out this r squared if you want to, but we know r squared is 625 because they give us this equation. But we'll do Pythagorean theorem anyways. 7 squared plus 24 squared equals r squared. 7 squared is 49. Figure that out on your calculator. Add them together, you get 625 equals r squared. And the square root of 625 must be 25. 25 is equal to r, so you got a 25 down here. And now they say, what is the value, here's the question, what is the value of the sine of theta? Well, sine of this reference angle, theta, is equal to the opposite over hypotenuse. The opposite side is 24, but it's negative because we're going down. The hypotenuse we just figured out was 25. And we're in quadrant 3, so we know that the sine is negative. So it looks like the sine is -24 over 25. And that's it for today. I think we got through all the exercises. So try your homework here on page 362, 366, and 7. And I'll post a couple of Delta Math problems also for today. Have a great day.